everyone, good day. This is Group 5, the activity number 7. We have the title, The Application of Codes to Mathematical Problem, and also we have the theme, The Creation of Codes that are beneficial to individuals and society. In our objectives, to encode and decode various types of information using coding scheme for identification, privacy, and security. To identify and comprehend what are coding scheme, binary number system, integers in computer, and operation of binary numbers. To acquiring new knowledge and applying it to all aspects of life that are involved in mathematics. In mathematical literature, an encoding or coding is a mapping of an arbitrary set A into a finite sequence or words over the sum alphabet B, while the inverse mapping is called a decoding. In this lesson 11, we will talk 4 topics, which is coding scheme, binary code, integers in computer, and lastly, operation of binary numbers. So before we proceed, let me show you our conceptual framework, and after that, we proceed to the topics.
Coding schemes, a convention that associates each character with a character set with a unique bit pattern, a binary representation of the integers from 0. So there are 3 common coding schemes. First is ASCII, or American Standard Code for Information Interchange. This is the most common format for text file in computers. An ASCII file, each alphabetic, numeric, or special character and representation with a 7-bit binary number and how 128 possible characters are defined. This is mainly used to represent data in computer. Second is EBCDIC, or Extended Binary Coded Decimal Interchange Code. Is a binary code for alphabetic, numeric characters that IBM or Internet Business Machines develop. It has a bit code, 4 bits for zone, 4 bits for digits, and allows 256 combinations and represents 256 unique symbols. This is mainly used in mainframe computers. Lastly, the Unicode, or Universal Code. This is the new ANSI, or American National Standards Institute. It supports most of the world's languages like China and Japanese and more, and becoming the Internet standard. It is 16-bit coding schemes that has a capacity more than 65,000 characters and symbols.
So we have 3 types of binary code, which is binary number system, binary file, binary digit, or bit. So what is binary number system? Binary number system works the same way as the decimal number system. For example, 10011 represents 1 times 2 to the power 4 plus 0 times 2 cubed plus 0 times 2 squared plus 1 times 2 raised to the power of 1 plus 1 times 2 to the 0 power, or 16 plus 0 plus 0 plus 2 plus 1, or 19. The second one is the binary file. It's a file whose content is in a binary format consisting of a series of sequential bytes, which is 8 bits in length. For example, the 64-bit sequence could represent 2 32-bit or 2 32-bit floats, or 1 64-bit or 4 16-bit shares of a single string of 8. American Standard Code for Information Characters. We can tell what data we have unless we know exactly how the data were written. The last one is binary digit, or bit. A bit is a single digit in the binary number. For example, the uppercase S is the American Standard Code for Information Interchange. The decimal value of 83, which is equivalent to the binary value of 01010011. The place values associated with the 0 bits are not added into the byte total.
A data type that represents a certain range of mathematical integers is known as integer in computers. In computer science, according to Wikipedia, different widths and ability to include negative values are both options for integral data types. As a collection of binary digits, integers are frequently represented in computers. The collection of integer size that are available different between various computer types, depending on the size of the group. A machine mechanism to represent a processor register of memory address as an integer is almost always provided by computer hardware, including virtual machines. The smallest addressable unit of memory was the term bytes. Originally meant 5, 6, 7, 8, and 9-bit bytes have all been employed in the past. There have also been computers that could only address 16 or 32 bits, a world address machine, or that could address individual bits, a bit address machine. When referring to bit and world address machines, the term bytes was typically completely avoided. In all cases, an 8-bit quantity is meant by the term octet. When machines with various byte width may need to connect it mostly employed in field or computers networking. The term world refers to a tiny collection of bits that are proceed simultaneously by processor built in a specific architecture. Thus, the size of a world depends on the CPU. Word size have varied widely when compared to conventional integer on the same system. A short integer can represent a full number with a narrower range and potentially less storage. A whole integer whose range is higher than or equal to the standard integer on the same computer can be represented by a long integer.
Let's explore a few different number systems that are in use today and see how with simple 3 rules we can build any number system we want. First, you add another digit to the left and make the right digit 0. Then again, go up until you finish up all your symbols on the right side, and when you hit the last symbol, increase the digit on the left by 1. Lastly, when you use up all the symbols on both the right and the left digit, then make both of them 0 and add another one to the left, and it goes on and on like that. Binary, we make the right digit 0 and add 1 to left, that is our next number is 10. Then we go up until we use up all our symbols on the right side, so the next number in line is 11. After 11, we put zeros in both these places and add 1 to the left and we get 100. Then 101, 110, 111, then 1000. This binary number system is based on 2 digits and each position is worth 2 times more than the previous position. These same rules apply to the octal and hexadecimal number system as well. With octal, we have only 8 digits to represent numbers, so once we get to 7, the next number is 10. And in hexadecimal, we have 10 digits and 6 letters to represent numbers. In that case, when we reach number 9, next number is represented in the letter A, next one B, likewise, we go up to letter F, and after F comes 10.
Operation of binary numbers. We take the set of numbers on which the binary operation are performed as x. The operation, addition, subtraction, multiplication, and division. In decimal examples, we have 329 from the base 10 or decimal. We have the total 329 in decimal. Binary examples, suppose the number 101 is in the base 2 or binary. In 4, 2 to the power of 2 we have 1. In 2, 2 to the power of 1 we have 0. In 1, 2 to the power of 0 we have 1. So 4 plus 0 plus 1 is equal to 5. So 101 in binary is equal to 5 in decimal. Example of binary addition. A few example binary addition are as follow. So we have here 10001 plus 11101. Solution. So we need to add first 1 plus 1 is equal to 0, then carry 1, then 1 plus 0 is equal to 1, then 1 plus 0 is equal to 1, then 0 plus 1 is equal to 1, then 0 plus 1 is equal to 1, then 1 plus 1 is equal to 0, then carry 1, then bring down the 1. So this is like final answer. So the resultant of the addition operation is 101110. Example of binary subtraction. Learn how to do binary subtraction using example 1010 minus 101. So solution, we need to minus first 0 minus 1 is equal to 1, then borrow 1 from the next digit. So 1 minus 1 is equal to 0, then 0 minus 0 is equal to 0. So next, 0 minus 1 is equal to 1, then borrow 1 again to the next digit, then 1 minus 1 is equal to 0. So that's the final answer. So the resultant of the subtraction operation is 0101.
Binary division and multiplication are both pretty easy operations. Instead of dealing with a lot of numbers, you just need to make sure to set the 1 or 0 in the right place. For this reason, you need to make sure you are also familiar with binary addition and subtraction. To perform a binary multiplication problem, we need to understand how addition works with binary numbers and follow the same process of multiplication, addition, we used with the decimal number. Let's say we want to multiply 4 by 3, which in binary will be 100 or 011 or it's 11 in the same. We start with the first digit, in this case 1, and multiply 100 by 1, which give the exact same number. Then we move to the second digit and proceed to the same. Since it's also 1, the number will remain intact. We just need to shift the number 1 digit to the left. Second digit multiplication, shift 1 digit. Later, since the last digit is a 0, we can skip it and start with the addition. Skip the 0 and start adding. 0 added to 0 is 0, and 1 added to 0 is 1. Final result of 4 times 3, we can verify that the result is 12 by converting the binary product to. To perform a binary division, you need to follow the same process as we do for dividing regular numbers, but in this case, we only need to decide that if going to be A1 or A0. To divide two numbers, which result is an exact division, we basically need to follow 4 steps: division, multiplication, subtraction, and the next digit. Let's say that we want to divide 18 by 3, which in binary will be 10010 divided by 00011. First, we need to identify digit by digit. Is 11 less or equal than 100? Yes, so in this case, we don't need to think how many times can 100 be divided by 11. Instead, we just add a 1 to the product.